Hello students, in the last lecture we discussed what is a complex number or what is the origin of the complex number. How do you get a complex number concept? By finding the quadratic equation. Whenever you have equation of this sort, okay, we found out the solution to be z is equal to minus b plus or minus under root b square minus 4ac divided by 2a. So depending on the value of this d, which is discriminant, okay, we can find out, okay, if the d is positive, you do get proper solution, but when this d is negative, then you obviously get to know the complex number concept. Okay, afterwards we have found out the representation also. So if at all you have z is equal to x plus iy is a complex number, so x is my real part, y is my imaginary part. Okay, now in today's lecture I'll introduce to you a new concept. Like we know now very well that yes, that the complex number z is x plus iy. Okay, and you know very well that x is a real part and this will be your imaginary part. Now what will show that a plane formed by the real and imaginary axis. Now means what? Suppose I draw a diagram like this and say this is my x-axis, this is my y-axis. On x-axis, suppose I take these points. Okay, this is suppose 1, 2, 3, 4, 5, 6. Obviously this is my origin, so second, third, fourth, fifth. So minus 1, minus 2, minus 3, minus 4, minus 5 and so on. On my y-axis I will be able to show this, and here also I'll show 1, 2 and this 3. Okay, so what is this will be called as? This is 1i, this is 2i, 3i, this is minus 1i, minus 2i, minus 3i and so on. So this is the plane formed by whom? The real axis, which is the x-axis, and the imaginary axis, which is the y-axis. Okay, so the graphical representation of the complex number on a complex plane is basically called as the Argand diagram. Suppose now I have the point P over here. Okay, so how will I join this P point? I'll join it over here, suppose to 3, and this is 2i, and join this also. So what will I say? This is my P x y or P of z. Fine. So how will I write my z as? This is x is 3 plus 2i. So this complex number z, which is 3 plus 2i, can be represented on a complex plane, and that diagram is called as basically the Argand diagram. Fine. Suppose I have the second quadrant and I or take a third quadrant. This is simple. This is plus plus, this is minus plus, this is minus minus, this is plus minus. Fourth quadrant. Suppose I have a point over here. Okay, this is this way and it is over here. Okay, so what will I say? This pz point, so z will be how much? This is minus 3 minus 3i. So this is the way I will be representing a complex number on a complex plane to show my Argand diagram. Okay, now after this, again the next topic, which is continuation of this, is rectangular form of the complex number. Rectangular form of complex number. Fine. So as again z is equal to x plus iy, suppose I show this xy plane, x-axis, this is y-axis. Okay, so what will I say? Suppose I take this point P, this is origin, join this point. Okay, this is R. So what do you say usually? You say OP is equal to under root x square plus y square is equal to mod of z. Fine. OP is equal to under root x square plus y square. You know very well how you draw this and get this value. So the point P coordinates will be xy. So the point P xy in the xy plane or on xy plane represents one and only one complex number z, right? Depending on obviously the coordinates. So this is my called as rectangular form because I had taken the two axes x and y, right? Now the next one. Next is what? This is again the Argand diagram will be shown in this fashion. Okay, so I can very well show 1, 2, 3 also. 1, 2, 3, and this will be 1i, 2i. So pxy or pz will be 3 plus 2i. Done. Now I'll take the second form. This was my rectangular form of complex number. Now I'll take polar form. Now as the name says polar, which means I will replace the coordinates x and y by r and theta. Okay, so what will I say? That in two-dimensional geometry, okay, we will take x and y in terms of x is equal to r cos theta and y is equal to r sin theta. Right? So what is the formula we are seeing? X square plus y square is equal to r square. So if we try to substitute the value, okay, how will you able to write? We'll write first z. Z is the complex number. So we'll write z is equal to x plus iy. What is the x value? R cos theta. What is the y value? I r sin theta. Right? So take r common and write cos theta plus I sin theta. Right? So this is my value of z. So how will I show this? This is the origin, this is the x-axis, this is the y-axis, this is the point P, join this OP, take this. So this is my x, this is y, this is r, this is theta. So x is equal to r cos theta, y is equal to r sin theta. From that we reached over here. Now this r and theta, this r and theta are real numbers, okay? So therefore the complex number z is expressed in terms of polar coordinates r and theta, okay? And that's the reason this is named as the polar form. Suppose now I want to know the complex conjugate of this z, okay? So will you write z bar? Z bar is the complex conjugate of this z will be r cos theta minus I sin theta. Okay? So if at all I take z mod z square, which is nothing but z into z bar. Okay? Substitute the value over here. So what will I write? R cos theta plus I sin theta multiplied by r cos theta minus I sin theta. Okay? So r will be r square. This is multiplication. Okay? So this will be, this is a plus b, a minus b. So this will be cos square theta. Okay? Plus, minus I square sin square theta. And what is I square? I square is minus 1. Minus I square will be plus 1. So we'll write r square cos square theta plus sin square theta. This is my mod z square value. Okay? So this means mod z is equal to r because cos square plus sin square is 1. Fine. So this r is basically what? Is the modulus of the complex number z. Okay? So from this Argand diagram, what we can write the value of cos theta and sin theta? Very simply, in a simple way. So we can write cos theta is equal to, what we write here? X by r. And sin theta is y by r. So x by r, but r is how much? Under root x square plus y square. And how much is my sine theta? It is y by r. So how much is r? It is under root x square plus y square. So the quantity theta is basically the phase angle or the argument of the complex number z. So these are the two forms we have studied, which is a rectangular form of complex number and polar form of complex number. And next we'll proceed, which is the exponential form of complex number. Third form is exponential form of complex number. Now, to understand this, what will I write? I already know that my complex number z is written as obviously x plus I by normal coordinate system. Then just now we said r cos theta plus I sin theta. Done. So now what we said, r is the modulus and theta is the argument. Okay. So now if at all I use the expression for e to the power x with the Maclaurin series, which I studied in your 11th, 12th. Okay. What is the formula over here? 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Right? So here we can write 1 factorial if you want. So this is the standard formula. Now what will I say? I'll say that my x is just a number. Okay. Now if I substitute this x by I theta, okay, I am replacing x by I theta. What will happen? E to the power I theta will be 1 plus. Okay. So I theta by 1 factorial plus I theta bracket square by 2 factorial plus I theta cube by 3 factorial and so on. Fine. Now we know very well that the cos theta is also given by a series which everybody must have studied in your 11th, 12th. So that is 1 minus theta square by 2 factorial plus theta raised to 4 by 4 factorial, right, etc. So if at all I replace, okay, over here theta by I theta, what will happen over here now? 1 plus I theta square by 2 factorial plus I theta raised to 4 by 4 factorial. Why did I do this? Because I square is minus 1. So this series is matching. Right? Similarly, now what is sin theta? Sin theta is the odd one. Cos is the even one. So how will I write this? This is theta minus theta square by 3 factorial. Sorry, cube. Theta cube by 3 factorial plus theta raised to 5 by 5 factorial and so on. Okay. Now suppose I multiply by sin theta I. Okay. So if I multiply by I, everywhere I have to multiply by I on R edges also. So I'll write I theta minus, okay, I theta cube b by 3 factorial. Now check I cube. I cube is I square into I. What is I square? Minus 1 into I. So minus I. Fine. So this will become how much? Already I am multiplying by I over here. But this is cube. So this will become I cube. Okay. So over here I'll have to change the sign to the plus because I square is minus 1. Okay. Next, plus I theta raised to 5 by 5 factorial. So if at all I add this cos and I sin theta, okay, this is one first term, this, then second term is this, third term is this, fourth term is this, and so on. So how will we be able to write now? Cos theta plus I sin theta, like in this fashion. So first term is 1, second term is I theta by 1 factorial. Third term will be this, I theta square by 2 factorial. Next term should be I theta cubed by 3 factorial, right? And so on. So this is nothing but cos theta plus I sin theta is equal to e to the power I theta. Very, very important expression. This is e to the power I theta. I got the same expression over here by taking cos and sin. So this expression is basically known as Euler's or Euler's formula. Very important expression. So what I can say, the complex number z, okay, how will I write z? R into cos theta plus I sin theta. Now I'll write R e to the power I theta, right? So this is my exponential form of a complex number, right? So this form of z, okay, is called the exponential form, and where again as usual r is the modulus and theta is the argument, okay. So it is expressed as product of the real part and the real part r and imaginary part e to the power I theta. This is what we have understood as far as three forms of the complex numbers is concerned: the rectangular form, the polar form, and the exponential form, okay. The next topic after completing these three forms is algebra of complex numbers. The first obviously is addition, second is subtraction, third is multiplication, and fourth is division. Now addition is obviously you need to add the two complex numbers. Suppose you have the first complex number z1 is x1 plus iy1, and suppose z2 is x2 plus iy2. Okay. So obviously I need to know the addition, which is z1 plus z2, in which I am interested. Okay. Now the sum z1 plus z2 is also a complex number z, right? So to understand this, what I did, I just drew this diagram over here. This is x-axis, this is y-axis. Now I showed first the vectors OP, OQ, and I joined OR. So this point R represents what? The sum is found by constructing the parallelogram. Which one? OPRQ. Okay, where OP and OQ are regarded as the position vectors of the points P and Q, obviously. Okay, and according to the law of parallelogram of vectors. Okay, what is OR? OR is nothing but OP plus PR. OP, okay, plus PR, obviously. But what is PR? But PR is equal to OQ. These two are same. So therefore, what is OR? OR is OP plus OQ. I replace PR by OQ. Done. So what is my OR? I said x plus iy, which is the complex number, and what is OP? x1 plus iy1, and second is x2 plus iy2. So this is z is equal to z1 plus z2. This is as simple as possible. Correct. So this is the way we will do the simple addition of the two complex numbers. Okay. On the same logic, we will move towards the subtraction of the two complex numbers. See now, subtraction of complex numbers. Here I showed this diagram. Now what does this diagram mention? That you have the two complex numbers z1 is equal to x1 plus iy1 and z2 is equal to x2 plus iy2, represented by points P and point Q. Right? Now, to show this on the organ diagram, which we did over here, now our job is to show the difference z1 minus z2, which is also a complex number given by z. Like here we had z1 plus z2 is equal to z. Here I want z1 minus z2 is equal to z. So what will I do? Now I showed this. So I'll say that the line QO, O is the origin. I just showed OP, okay, P point and Q point. So P point is the OP will be my Z1, OQ will be my Z2. Okay? So now the line QO is produced so that length of ON, okay, this length ON is equal to length of OQ. This and this is similar. But vector notation which says what? OQ is equal to minus ON. Vector, okay? OQ is minus ON or ON is equal to minus OQ. Okay? What does this give me? That the vector ON is position vector of the point N which corresponds to the complex number minus Z2. Right? Minus Z2. So the point S, okay, representing the difference which we are interested, Z1 minus Z2, is obtained by constructing a parallelogram. Which one? OPSN. OPSN. Fine. So over here, what is happening? OP and ON are the position vectors of the point P representing the complex number Z1 and ON representing the complex number minus Z2. Just now we said minus Z2. So according to law of parallelogram of vectors, what we can write? Vector OS is equal to ON plus NS. Okay, this OS is equal to ON plus NS. Fine. But what is NS? NS is same as OQ. Okay, but NS is equal to OQ. So I can write OS is equal to ON plus OQ. Fine. So OS is equal to OQ. Write first this and then write ON. Okay, which is ON. But what I said, ON is equal to minus Z2. So we can say Z is equal to Z1 minus Z2. Okay, ON is minus OQ. OQ is your minus Z2. So Z1 minus Z2, which we have got it. Okay, so basically X plus IY is equal to Z1 minus Z2, which is X1 minus X2 plus I Y1 minus Y2. Like here, what we could have written, X1 plus X2 plus I Y1 plus Y2. Like here we wrote X1 minus X2 plus I times Y1 minus Y2. Right? So next video lecture we'll try and study the multiplication and division of the complex numbers. Okay, so anything not clear, feel free to ask. So today we have studied obviously the Argand diagram first, then the three forms of a complex number, and then the algebra of complex numbers. So we have finished with simple addition and subtraction. Now obviously multiplication and division we can't show in this fashion, so we'll have to use the another form, which is the polar form or the exponential form, that will help us to show the multiplication and division of the complex numbers. Okay, go through it. Any difficulty, feel free to ask. Thank you very much.